Hey everybody, sorry I couldn't be here live. My name is Jim Birnam. I'm the mechatronics teacher here at Silicon Valley CTE. I'm super excited about this next year. This will be my third year teaching this class, so it's kind of settling down and we're kind of getting things organized. So this will be the best year yet. Sorry I can't be there live. My superintendent Alyssa asked me to host or to be on a part of a panel on manufacturing with the San Jose Manufacturing Organization, and so I couldn't be here tonight. But I'm going to give you some overviews. I'm going to have some more video attached here to talk about the class. Hopefully I'll answer many of your questions, but if you have questions, please send me an email. I'll give you my contact information as well. And send me email, and I'm certainly happy to chat with you. I probably will send some mail over the summer to all the new students as they've been registered in the class, and kind of get folks ready for next year. I'm super excited. See you in a bit. Okay, so why don't we start out by watching just a couple videos. Our film and arts class created a promotional video for us, so we'll watch that, and then we'll watch a couple other YouTube videos that popped up with the class, and then we'll actually talk about a bunch of stuff in the class. I'll go through an overview of what the class is about, and then I'll just have a bunch of random comments about, homework and how we work in the class and equipment we're going to use and robot club and all that kind of stuff. So stay tuned. So we live in Silicon Valley, and this is the epicenter of technology. And so here at Silicon Valley CTE, we're trying to create students who have the skill sets to actually work in this valley.
When I joined Mechatronics, I had no experience whatsoever coding or creating robots. I feel this class is very beneficial living in Silicon Valley due to the technical advances that are happening in this day and age.
So mechatronics is mecha, mechanical engineering, and tronics, electrical engineering. And when you mash those together, you get fire-breathing robots. But the class really is an engineering class. So if we're looking at the notable projects, the major projects that we do in this class, we will of course learn C++ and program Arduinos, and that's a little hardware board, and we'll learn how to get signals in, switches, sensors, motion sensors, those kinds of things, and then control motors and stuff like that. When they gain that foundation, then they can take that knowledge and actually build a differential driven robot.
In this class, we pretty much learn how to code. That's like the bottom line. And we also learn how to pretty much put together robots.
A lot of the students who are thinking about taking this class, they're not sure. They've never done a nerdy thing like that, and my answer is, come try it out. Take this. What'll happen is you'll learn, I don't really like to program, or I don't really like to play with robots. But what you might find is that I'm a really good programmer. I love to program. I didn't know I liked to do this, but I love doing it. And so that's why I say, come try this class, because you might find that you really actually excel and are really good at it. This is the first year of this mechatronics class, so we had never had this class before, so I'm building this class from the ground up, and it's kind of a learning experience for me as well as the students, but come and enjoy and learn some technology.
Hi, my name is Benigno Escalera. I'm from Santa Clara High School. Today we're working on a kinetic art. We have two LEDs on top and a DC motor on the bottom, and this is our power supply. It's 12 volts. We're just making a table right here, and we're having a figure rotate on it, and as the LEDs flash on it, on the other side, it's like a shadow, so it makes like a small short story.
Hi, my name is Jim Birnam. I'm the mechatronics teacher here at Silicon Valley CTE, and today we're doing a kinetic art project. So the idea here is just to create a shadow box that's got some motion in it, and so my students they actually soldered up and created the super bright LEDs. They created little turntables. They learned how to use motors, and so a whole bunch of engineering went into this art project, because engineering without art is just calculating. All right, this is Mr. Birnam in 60 seconds. So I was born in LA, Los Angeles, California. When I was 6 months old, we moved to Bogota, Colombia. My dad was an accountant, and he worked for Winnie Murray, Ernst & Young now. And so I spent my first 5.5 years in Bogota, and then we moved to Brussels, Belgium. And so then I spent the next few years till I was just turning 12 in Belgium. And so in Bogota, I learned Spanish, and then in Belgium, I got all confused and maybe learned a little bit of French, but not really. And then when I was 12, we moved to Cleveland, Ohio. And there I got to see 2 lunar eclipses. I got to meet John Glenn. And then my dad changed jobs. He could go work for a bank in London, he could go work for a bank in San Francisco, or he could go to work in Bartlesville, Oklahoma. He chose Oklahoma. And so I spent my last 2 years of high school in Oklahoma, but then life sped up. I went to a year of college out of Brigham Young University in Utah. I spent 2 years in Chile. Then I came back and spent a semester at Oklahoma State University. All right, this is Mr. Birnam in 60 seconds. All right, I'm going to redo this because it's more than 60 seconds. But so life sped up, and I married my high school sweetheart, and then I went back to school. Had 4 more years of school at Brigham Young University. Got my degree in electronics engineering technology. So life as an engineer. I was an intern and then summer internship at Beehive Telephone, super tiny company. Then I worked came out here to California, and I worked for Amdahl in Sunnyvale. They no longer exist anymore. But I had a friend who worked over at a company called Xilinx, and I went over one Saturday, and he showed me all the cool stuff they were doing, and I said, oh my gosh, I have to have a job here. And so I went and figured out how to get an interview, and 25 plus years later, that was basically my whole career. And now, life as a teacher. Last year, I've taught some summer camps. In 2016, I taught cybersecurity, and now this is my 3rd year of teaching mechatronics. Mechatronics engineering is mecha, is mechanical engineering. Tronics is electrical engineering, and of course that equals fire-breathing robots. That's what we're going to do this year, is fire-breathing robots. Thanks. All right, so let's learn a little bit about mechatronics. And I'm not expecting any of my students to actually have any experience using electronics or programming or robots or anything like that. It's all going to be taught in the class itself. And of course, that equals fire-breathing robots. So what are we going to learn in this class? All right, it's a hands-on physics class, so it satisfies A to G D science requirement, so it counts as a physics class. We're going to learn about AC/DC circuits and general electronics, fundamentals like that. We're going to learn digital logic. We're going to program. We're going to learn to program in a number of different languages. We'll talk about that in a second. We've got some 3D printers in the room. We're going to learn a little bit about pneumatic systems. some programmable logic controllers, and then of course, lots of robotics. So as far as AC/DC circuits, right, we're going to learn Ohm's law, series to parallel circuits, and lots of digital logic. Now, the tools that we're going to use for programming is this Arduino and a Raspberry Pi. We're going to learn to program in C++ with the Arduino, and we're going to learn to program in Python with the Raspberry Pi. And like I said, most of my students have never had any programming, so don't let that scare you. We're going to learn from the very, very beginning on how to program. We've got 3D printers, and so we're going to do some 3D design. We'll learn how to, do some CAD drawings in 3D CAD tools, and then print those out. Like I said, we're going to play around a little bit with some pneumatic systems. And then, of course, programmable logic controllers, industrial controllers, and industrial robots. I have this FANUC robot in my classroom, and we'll have some modules where you will learn to drive that robot, use that robot, move it around, and do stuff with it. So that's going to be super cool. We also do lots of competitions with our little robots. So we build little don't drive off the table robots. We play with these VEX robots. We build some little submarines. And we have opportunities to compete locally against other high schools or regionally and state. And this year, my VEX competitors built some little VEX robots, and we competed in Skills USA, and they won 3rd place in regionals and placed about 5th in the state. So that's really cool. So everything I do is hands-on, lots and lots of hands-on, lots of project-based learning. So you'll be doing things individually, but you'll also be doing things in teams. And so, for example, one of the very first projects we do is this Arduino Rube Goldberg project, where we learn the basics of programming with the Arduino, but then we end up building a system that has switches and motors and all kinds of stuff, where you'll be able to control your environment with the Arduino. Be able to sense when something happens with light sensors or motion sensors, and then control a motor to flick a ball or push a car or do tip over some dominoes or something like that. And like I said, it's basically it's you got to use an Arduino, use a motor, and use some sensors and make stuff move. And so that's always fun, because you have this great big project that goes from team to team to team to team, doing crazy stuff. But it's a really good project because it causes students to have to interact as teams. It causes them to negotiate with their teams before and after them. It also allows them to document the whole process. They document what worked, what didn't work, how they solve it. They've got to have some source code, got to have code that they've written, and they present. They present their section and how it worked and how it interacted with others. So it's a really great project, and all my projects are kind of like this, where you're gonna have a presentation part of it, you're having some documentation part of it, and then lots and lots of hands-on parts. Plus, we're going to do Halloween. Last few years, we've been doing a haunted house here at the school, and my students get to build and create stuff that work inside the haunted house. So that's cool. So meet my students, right? You come from all over San Jose and Silicon Valley. Some of you know absolutely you're going to college right after high school. Many of you, this might be, you might be the first person in your family considering even going to college. Half of you don't even know, what you're going to do after high school. And some of you tentatively say, will there be a lot of math? Well, there'll be some math, but we'll learn all the math that needs to be learned in class as part of the projects. So I'm not expecting you to be a super math whiz even coming into my class. So I'm glad you decided to take a chance on me in my mechatronics class. It's going to be super fun. We're going to do some super fun stuff, and you're going to be able to excel and learn and do all kinds of things and really have control of the projects that you work on. My hope for you is that you really get a good knowledge of hands-on engineering. If you don't know what you're doing after high school and you don't know if you're going to be going to college, well, the plan is that you will be able to get a FANUC robot handling, tool handling certification. You will have exposure to programmable logic controllers and industrial control. So being able to go into factory automation and those kinds of things, those entry-level jobs, should be able to go into some of those jobs right out of my class. But if you're going on to college or thinking about going to junior college, this is a great pathway for electrical engineering, mechanical engineering, mechatronics engineering, computer science. All of those are great pathways for this class. And of course, fire-breathing robots, and you can't go wrong with that. Hey, thanks, and I'll maybe have a couple more videos, but certainly if you've got any questions, I'll give you my contact information as well, and you'll be able to email me and ask me any additional questions you want. All right, so let's explore the question of how hard is my class? So I have really high expectations of my students. I'm expecting you to work. I'm expecting you to learn. I'm expecting you to be able to focus on the tasks that we do. But I'm also expecting that most of you, if not all of you, have not had any coding classes, have not had any electronics classes, haven't played with robots at all. So I understand that you're going to come to my class hoping to learn electronics and hoping to learn engineering and try something out that maybe you haven't ever thought about trying, but I don't expect you to know very much about this topic. And that's what we're going to do, is we're going to learn that in this class. So, as I said, my expectation is that you don't have that experience. If you do, that's great, and you'll just be ahead and be able to work on projects that we can, step up. But if you don't, we're going to learn how to code from the very beginning. We're going to learn electronics from the very beginning. We're going to learn to play with robots and program robots from the very beginning. So know that I'm going to expect a lot of work out of you, but know that we are going to learn how to do that in class. And I will provide the instruction and the lab and the experience and the time for you to be able to learn those things. Muy buen días. Yo puedo hablar español, así que si habla español, puedo ayudarle con las tareas o laboratorios o otras cosas. Algunas veces permite que los estudiantes se puede escribir algunas tareas en español. Si es más cómodos escribir en español que en inglés. Sí, puedo hacer eso a veces. I'm also trying to learn some Mandarin, although I only know tiny bit, but I'm going to be, this summer, I'm actually going to be in Taiwan, and so I want to learn a little bit of Mandarin as well. They say, if you speak 3 languages, you're trilingual. If you speak 2 languages, you're bilingual. And if you speak 1 language, then you're an American. So I really applaud folks who learn a second language, third language, fourth language. I got a friend of mine, he's knows 6 languages. My dad can speak 8 languages. It's crazy. I just speak Spanish, a tiny bit of French, and English. Anyway, thank you. All right, so let's talk about homework. We're not going to have a lot of homework. We'll have some. Most of the time it'll be, go watch this video and be ready to talk about this tomorrow, or go read this article and answer these 4 questions. Many of the assignments that I do in my classroom, especially at the beginning of class, usually is some writing assignment where you have to answer some questions. I expect them to be turned in, but you don't necessarily have to do them right then. You could do them at a different time. Or if you don't get them done, you can turn them in late. I expect that you get your assignments turned in, though. So, some points are better than 0 points. And if you turn an assignment in and I grade it and you get a C on it, I'm expecting you to actually return it in for a better grade, and I'll give you more points for doing that, right? Because I think it's better to improve and learn than just be graded on something and then that's it. But yeah, so not a lot of homework. Pretty much everything we do will be done in class. The reason why is because most of the time we're using equipment or we're using lab materials that are in class, and you don't have access to those. So, like I said, lots of assignments, but not very much homework. All right, so I'm going to talk about some just random stuff. So headphones. I want every student to have a pair of headphones. We're going to watch videos, and sometimes it's going to be at your own pace. And so I'm going to want all the students to have a pair of headphones that they can plug into the computer. So if you got, and they can be just cheap headphones. And I'm going to have a bin of, dollar store headphones. If you want to buy them for me for $1, I'll have headphones virtually anytime you need to buy one. But you keep those in your bin, and then you have them in class, and you never have to worry about, I don't have any headphones. Now, I need these to be headphones you can plug into the computer. So just standard headphone jack. Sometimes some of your phones will have specialized headphones that only plug into the phone, but not the computer. And so make sure that it's headphones. Yeah, headphones. All right, let's talk about class equipment. So we're going to have a lot of equipment in class, but there's also going to be some equipment or lab materials that each student's going to get. So every student's going to get like an Arduino, which is a little microcontroller board that they're going to use throughout the year. They're going to go to a Raspberry Pi kit that they'll use throughout the year. They'll get some tools. They'll get like a screwdriver and some pliers and some other stuff like that. They'll get a pair of safety glasses. I'm expecting you to keep track of those. All right. They're going to get checked out to you, and at the semester or at the end of the year, they're going to get checked in. And my expectation is that you've kept track of them. So that's going to be one of the things that we're going to work on very quickly right at the beginning of the year, making sure that you keep all your stuff in your bin and it's put away, and we're going to lock them up between class. And so, once you're out of class, you shouldn't have to worry about it. But while you're in class, you have to take care of your materials. So at the end of the year, if you don't have an Arduino, then I'm expecting that to get replaced. Arduinos are, $10 to $15 a kit. Raspberry Pi kits are like $35 a kit. Tools are, so, I mean, there's probably about $100 worth of materials that you're going to be responsible for, and you need to keep track of that. Phones. Let's talk about phones. So I'm struggling with phones. Bless you, but students, man, you just have a hard time not playing with your phones, and I just can't do that. There's gonna be times where I'm gonna want you to get your phone out. I'm gonna want you to get your phone out, and you've done some really cool thing. I want you to Snapchat it and post it on social media and let people know what cool stuff you've done. But virtually, other than that, we just don't need phones. We're not going to be listening to music, and so you don't need your phone to listen to music. You don't need your phone to be texting people during class. You don't need your phone to be watching, videos or playing games during class. So we'll have a chat about phones at the beginning of the year, but know that you really just aren't going to be using your phone in my classroom, and have that be an expectation from the beginning, that's what the rules are going to be. I hope that's not a problem for you, but we'll practice that first week or so of school and make sure that everybody's got a good understanding of phone use in my classroom. Thanks. Robots. Let's talk about Robot Club. So I do Robot Club basically as part of class. My expectation is that every student in my class is part of Robot Club. And we typically do Robot Club, those kind of projects, Wednesdays and sometimes part on Fridays, and depending on as we're getting closer to a competition and students are going to competitions, then we'll do a little bit more. But basically, we don't have an after-school program, and I'm working on trying to figure out how to maybe do that. But it's just kind of odd how it works at this school, because students get on the bus, they come, then they get on the bus and they go away, and then they're not here. And so having an after-school robot club is difficult. So what I do is I do it in class. Just part of our 2 hours or 3 hours of class, we'll have a robot club a couple times a week. Every one of my students will be on a team that'll work on some robot club project. Not every team will be going to actually competitions. Those that want to will make that arrangements. So what do? We do Vex. That's kind of an erector set style robot. We do some tabletop robots like Don't Drive Off the Table. We do some submersibles, ROVs. I've got a pool, and we'll do some little robots that go in the pool. And then we do just all kinds of random stuff. Whenever I find some competition that we can get into, I try and get students to be involved. So we got cut off with Robot Club, but we do some other competitions. I've got some hydrogen-powered cars, that little race cars, and then we also we're working on just some others. I've got some little remote control cars that we've hacked with Raspberry Pis and turning them into autonomous vehicles, and there's some competitions for that as well. So students, be ready. We're going to do some really crazy fun things and let you have a lot of choices on kind of competitions you do. Parents, I'm going to need help when we go to competitions. So I'm going to need folks to drive. Sometimes they're not. Sometimes they're an hour away. We'll just need some help, some support. So please be ready to jump in and help with that as your student is involved in some of those competitions. Woo! So I do get the question from parents, how can I help in the classroom? Can I come work in the classroom? Can I, go on field trips and things like that? And the answer is, a qualified yes. So I'm totally game for that. I can always use help in class during labs, during kind of our robot club time frame, which we do during class, and stuff like that. So yeah, if you wanna come, be in my classroom, work in my classroom, we can work that out. The other thing though is that if you are someone who has some expertise or knows someone and says, oh, this person is really good with robots, or they work at this really cool place and they would love to come talk to your students, I would love to have guest speakers. And my goal is to have one every other week, maybe even every week if I could do that. And so please, if you know somebody or you want to be involved with my class, please let's chat and kind of figure that out, put a schedule together, and do some stuff like that. Especially if you know places that would be interesting to go for field trips. We do get some budget to do field trips, and so I'm always game to go off and do field trips as well. So yeah, talk to me. I'd love to have you in my classroom. All right, so that's it. I probably got tons of other stuff that you might have questions about. I'm going to publish a bunch of stuff. I'm going to have a handout that has contact information, a link to a website where you can get more information, potentially a syllabus that you can look at, a bunch of other stuff. So stay tuned, and I'll post at the end of this video, I'll post my contact information as well. But like I said, I'll have a handout that you can do. All right, so I'm super excited. I'm super excited. Can you tell that I'm excited? It's going to be a super great year. All right, see you later.